Hello everyone, so we will cover AVL tree in this video, and AVL tree is a self-balancing tree. The initials are from the scientists who discovered the tree, so Adelson, Welsky and Landis. There are two conditions for an AVL tree. One, that it has to be a binary search tree, meaning the left subtree nodes are less than the root and the right subtree nodes are greater than the root. And the second condition is that the balancing factor should be in the range of 0, 1 and -1. And what do we mean by balancing factor? It is the height of left subtree minus height of right subtree. So let's have a look. For example, we have a tree here. Now 80 is the root. On the left hand side, all the nodes are less than 80. On the right hand side, all the nodes are greater than 80. So let's calculate the balancing factor for each node. We know that the leaf nodes have 0 balancing factor because they don't have any further nodes. Okay. For root 80, the height of left subtree, meaning from the leaf node 40 to 80 we have two edges, and in the right subtree we have one edge going from 100 to 80. So 2 minus 1, left height of left minus height of right subtree, is equal to 1. 1 is in the range of 0, 1 and -1, and therefore this is an AVL tree. Okay, if we calculate balancing factor for 50, again it will be 1 minus 1, so 1 from the left side, 1 from the right side, and 1 minus 1 is 0. Again it is in the same range. If we calculate for 100, it's a leaf node, so it is 0. 100, 60, 40, they are all, the balancing factor is 0 because they are all leaf nodes. So this is an AVL tree. Let's look here if this is an AVL tree. Now again, the condition is, first it has to be BST, binary search tree, meaning the left subtree nodes should be less than the root and the right subtree nodes should be greater than the root. So if we see 40, 50, 30, 20, they are all 35, 45, 60, they are all less than 80, and 100 is greater than 80. So BST condition is fulfilled. The second condition is balancing factor, which should be in the range of 0, 1 and -1. So let's calculate the balancing factor for each node. For 20 it is 0, for 100 it is 0 because it's a leaf node. For 30 the balancing factor is 1 minus 1, so left hand side minus right hand side, which is 0. For 40 it is 2 minus 1, which is 1. For 50 it is 3 minus 1, which is 2, so it is not in the range. Same for 80, it is 4 minus 1, which is 3. Why 4? From the leaf node 20 reaching to 80, there are 4 lengths or 4 paths. So the height of left subtree is 4, height of right subtree is 1. So 4 minus 1 is 3, which is not in the range of 0, 1, -1. So this is not an AVL tree. Is this an AVL tree? So again, 0 for leaf nodes, which is 50, 90, 110. They are all having balancing factor of 0. For 80, the balancing factor will be 1, -2, which is -1. So it is an AVL tree. Again, this is a complete binary tree. Complete binary tree meaning that every node has maximum of 2 children. And if we calculate the binary, the balancing factor, it is going to be in the range of 0, 1, -1. It is going to be 0 exactly. For complete binary tree, it is always 0 because there are exact number of nodes on the left subtree and on the right subtree. So if you see for 80 it is 2 minus 2, which is 0. For 50 it is 1 minus 1, which is 0. For 100 it is again 1 minus 1, which is 0. So complete binary tree will always have zero balancing factor for each node. And so we can say it is an AVL tree. Now there are 4 rotations in AVL, which is LL, RR, LR, and RL. We will cover those in the next class.